Hey there, in this video I'll be going over learning target 21 where we're doing integrals now. Throughout this course, first you learned limits and then you learned derivatives and now you're learning integrals. Integrals are like the third big thing in calculus. Um, Super duper important in physics. So many physics equations are derived using integrals. Um, It'll be prevalent in all your engineering studies, so it's great to get a good foundation. It's also a core learning target, so make sure you pay attention. Get this one knocked out early. So in all these questions, we're asked to find the antiderivatives, and I noticed that none of them have integral bounds, which means they're indefinite integrals. So I'm going to write up here in big letters, plus c. We have indefinite integrals, so we need a plus c at the end of our solutions. And I'll remind you that throughout this video. So let's jump into A. We need to find this antiderivative. And so first term, I'll just use the reverse power rule. So I will raise the exponent to 4. Yep, I'll raise the x to 4. And then I will also divide by that 4. Negative 5/4 x to the 4th. Minus the x will be raised to the second power. So I'll divide by 2. And then just like derivatives, when I take the integral of e to the x, it stays the same. And then I need a plus c. Boom. Not too bad. Alrighty. I'm going to do a little bit of rewriting for this next integral to make it easier to use the reverse power rule. I'm going to recognize that this is the same as 1/6 times x to the negative 3 minus 3. I'll leave it as 1 over x actually. And then same with that third term. All right. So the first term here, we're just going to be using the reverse power rule again. Adding 1 to the exponent, we'll have x to the negative 2. And dividing by that negative 2, we will have a negative 1/12. And then I have negative 3 times 1 over x. So if I add 1 to that exponent, it would have like this already has an exponent of negative 1. If I add 1 to that, I get x to the 0. But you may remember that the derivative of ln of x is equal to 1 over x. In this case, I have a 1 over x. I'm going to take the integral. So it's actually just ln of x minus 3 ln of x. And then this last term, maybe thinking, whoa, that's pretty crazy to solve an integral for. But the integral or antiderivative is arcsine. That's just knowing the definition of what arcsine is. Looking at it, there really isn't an intuitive way to solve for it. All right, now we're dealing with some trig in part C. So integral of sine will be negative cosine. That's because if I take the derivative of cosine, I get negative sine. And then secant times tangent, if I want to take the integral of that to get any derivative, I get secant, because the derivative of secant is secant times tangent. And then plus c again. Now I'm dealing with a fraction in D, but I don't think there's really a quotient rule to use. But fortunately, there's only one term in the denominator. So what I can do is I can rewrite this by dividing each term in the numerator by the denominator. So I'll have 3x to the 4th over x to the 4th minus x cubed over x to the 4th plus 6x squared over x to the 4th dx. And that's just equal to, simplifying even more, I got 3 minus 1 over x plus 6x to the negative 2 power dx. And that integral is not too bad to solve. Integral, or any derivative of 3 is just 3x. We talked about the negative 1x earlier. That will be a minus ln of x. And power rule for this third term, add 1 to the exponent. That leaves us with an exponent of negative 1. We need to divide by negative 1, so we just get negative 6x to the negative 1 plus c. Okay, not to be a dead horse, but remember, plus c for indefinite integrals, absolutely crucial. And rather than just go through all these integrals in summary, I will say that whenever you solve an indefinite integral, you're left with some function of x. You can check your work by going back and taking the derivatives of your solutions. In every single one of these, you'll just end up with the original function. I'm not going to do that on camera because you guys already know how to do derivatives pretty well. But if I did it really quickly, let's see if I take the derivative of this, I get the term. Same with this, same with this. Derivative of c is a constant. Derivative of some constant equals 0. That's why it's not in this original function. Same here, the arc sine, the ln, and the x term. If I take the derivative, I just get the original function, original function, original function. So yeah, that's a good way to check yourself. If you have extra time, I would say there's really no reason not to. And if something's not working out, go back and check your integral. I guess that assumes you have a pretty good grasp of derivatives, which I think everybody does. So if they aren't matching, go back and check your work for both the integral and the derivative, and then eventually just tweak those and make sure they end up being the same. Yeah, I hope all this helps. Once again, integrals are pretty important for both calculus and other applications in math and science, so it's good to get a grasp of it early on.